Welcome to Currents Chem World. In this, let us solve a few problems asked in various competitive exams. The first problem is mass in grams of copper deposited by passing 9.6487 ampere current through a voltmeter containing copper sulphate solution for 100 seconds is. There are four options they have given. They have given molar mass of copper or atomic mass of copper 63 gram per mole, 1 Faraday. 1 Faraday equal to 96,487 coulombs. Let us see the given data. In this problem, they have given the current passed and how much time they have passed the current, that is 100 seconds they have passed. The current is this ampere, and also they have given its molecular mass or atomic mass of copper, and 1 Faraday equal to 96,487 coulombs. According to Faraday's first law, the amount of copper deposited is directly proportional to the I into T, where I is the current, T is the time. So it depends on how much current you pass, how long you are passing the current, where Z is the proportionality constant called electrochemical equivalent of copper in this case. For example, when W equal to Z, when 1 ampere current is passed for 1 second, when 1 ampere current is passed for 1 second, then W equal to Z. What is the reaction occurring during deposition? Copper 2 plus 2 gains 2 electron to become metallic copper gets deposited. In this case, 2 electrons are accepted by copper 2 plus ion. For aluminium, it will be Al3 plus. For sodium, it will be 1 electron. So there are two moles of electron. Now 1 Faraday is nothing but charge on 1 mole of electron. So you have 2 Faraday. We need 2 Faraday to deposit atomic weight 31.5 gram. Therefore 2F Faraday. Why? In the case of aluminium plus 3 electron gives aluminium. Therefore 3 Faraday electricity is required to deposit atomic mass of aluminium. Okay, so 2 into 96,487 coulomb deposits 31.5 gram. Now number of coulombs passed equal to, now from the given data, how many coulombs current we have passed? We have passed I into T, therefore 9.6487 ampere into 100 second, therefore this much coulomb of current we have passed. See, we know this much coulomb deposits 31.5. Therefore, how much this coulomb of electricity will deposit. So mass deposited is equal to, okay, that is mass deposited by the passage of this much coulomb of current. Therefore 31.5 divided by, for 1 coulomb, for 1 coulomb means divided 2 into 96,487 into this much coulomb. We are passing only this much coulomb, therefore into 964.87, the answer is 0.315. Let us see the second question. Which plot of L and K versus 1 by T is consistent with the Arrhenius equation? The answer is, there are 4 graphs given. Which plot is correct one? In this case, D is correct. Let us see how D is correct in the next slide. According to Arrhenius equation, the rate constant is given by this formula, by this equation, K equal to A into e power minus EA by RT, where EA is the activation energy, R is the molar gas constant, T is the temperature of the reaction, A is the rate constant, where A is called pre-exponential factor. Let us take logarithm on both the sides. Let us take logarithm on both the sides of Arrhenius equation. Therefore, ln k equal to ln A plus ln e power minus EA by RT. So, ln k equal to ln A, this will be minus EA by RT. This equation is in the form of straight line equation. This equation is in the form of straight line equation, y equal to mx plus c. Okay, so this is c, integration constant. Okay, and 1 by t is variable. Therefore, m is equal to EA by R. Let us take in the y-axis. Ln k. Let us take in the y-axis ln k, because okay, y. In the x, let us take 1 by t. Okay, here this is variable 1 by t in the x-axis. So x. Now, so this is the plot. Okay, here intercept, where c is called intercept along the y-axis. This is the intercept c. That is ln A. This is ln A. And this is negative slope, because slope is negative. As you see, negative slope. Slope is minus, not plus. Here minus. Therefore, this will be the negative slope. Therefore, m equal to EA, slope equal to EA by R. In the intercept along y-axis equal to ln A. So, this is the correct plot with the negative slope. Let us solve the third question. The plot of osmotic pressure versus concentration in moles per liter for a solution gives a straight line with the slope 25.73 liter bar per mole, full stop. The temperature at which the osmotic pressure measurements is done is, there are 4 options. The answer is 37 degrees Celsius. They have given R equal to, in liter atmosphere, liter bar, R equal to 0.083, because the slope is given in liter in terms of liter units. Let us solve this question in the next slide. In this problem, they have given slope equal to 25.7 L bar mole inverse, R equal to this. Osmotic pressure, they have plotted osmotic pressure versus concentration. In this, they have plotted osmotic pressure. So, the osmotic pressure is given by, we know that pi equal to CRT, where pi is osmotic pressure, C is the concentration, moles per liter, R is the molar gas constant, it is given here, and T is the temperature at which the experiment is carried out. So, we can write this RT into C. This is the straight line equation. We can compare this equation to a straight line equation, y equal to mx plus c. In this case, c is integration constant, it is equal to 0. It is equal to 0. Therefore, y equal to mx only. Let us take osmotic pressure pi in the y-axis, because y-axis, and let us take x concentration in the x-axis. In this case, a straight line is obtained. It is passing through the origin, because c equal to 0 here, plus c is, there is c equal to 0 in this case, integration constant. Not this, c is an integration constant. This is c is the concentration per mole. So the straight line is passing through the origin is obtained. There is no intercept. Intercept c equal to 0. Therefore, slope equal to, this is slope, m equal to RT. In this case, they have given slope. What is slope? So slope equal to here, and equal to R they have given into T. So T equal to 31, temperature equal to 310 Kelvin. In terms of Celsius, subtract with the 273 to give 37 degree Celsius. This is the answer. Which is not a redox reaction. Which is not a redox reactions. They have given 4 reactions. In this, one of the reaction is not a redox reaction. How do we find out? We'll see. See, in this, zinc is in 0 oxidation state. So zinc is oxidized to 2 plus. And copper sulphate, in copper sulphate, copper is in 2 plus oxidation state. It is reduced to copper 0. So it is a redox reaction. Next, you see chlorine. Chlorine is in the plus 5 oxidation state, because x minus 6 equal to minus 1, that is plus x equal to plus 5. Iodine is in 0 oxidation state. In any molecular gaseous form, 0 oxidation state. KI3, similarly, Cl is plus 5, I is minus plus 5. So you see, and chlorine gas is 0, and chlorine is reduced, iodine is oxidized. So it is also a redox reaction. The next case, H2, it is in molecular form, therefore its oxidation state is 0. Chlorine in its molecular form, oxidation state is 0. In this case, chlorine is plus 1. Chlorine is, hydrogen is oxidized, chlorine is reduced by accepting the electron, minus 1. Therefore, it is again a redox reaction. Let us see the fourth option. Barium chloride reacts with the sodium sulphate to give barium sulphate precipitate. This is called a precipitation reaction. In barium 2 plus, so Cl minus 1 here, okay, 1 plus sodium, Na plus, Ba2 plus, SO4 2 minus, SO4 2 minus, Na plus. So here barium, there is no change in the oxidation state of barium, there is no change in the oxidation state of sodium, and also chlorine and also sulphate. Therefore, it is the fourth option is correct. It is not a redox reaction. Thank you for watching. Please subscribe Currents World. Thank you.